Hello, and welcome to this demo of the Forta protocol. My name is Philip, and I am a security researcher with Arbitrary Execution, a Forta development partner. Forta is a permissionless runtime security network designed to provide threat detection for the decentralized economy. Let's take a look at a real-world example to see how Forta could have helped detect and mitigate it. Badger is a DAO focused on bringing Bitcoin to DeFi across multiple blockchains. Users simply bridge their Bitcoin into Badger, where they can select from several strategies to earn interest. The protocol has nearly $1 billion of total value locked with nearly 31,000 users. In December, the protocol was the target of a phishing attack where users unwittingly approved malicious transactions. An attacker used a compromised Cloudflare API key to periodically inject malicious scripts into the front-end Badger application. The script inserted additional transactions in the midst of victims' legitimate transactions, giving the attacker permission to drain tokens from users' accounts. Some users of the protocol noticed anomalous behavior and raised questions to the Badger Discord team, but the behavior was deemed most likely due to user error. An estimated $120 million was stolen, with one user alone losing $50 million worth of Bitcoin. Let's take a look at the mechanism used by the attacker. When users interact with decentralized applications, they may be asked to approve a smart contract to spend their tokens. For example, when performing a swap on Uniswap, the user must approve the contract as a spender for it to transfer the user's tokens into the pool in exchange for tokens that are taken out of the pool. More generally, a user's approval can be given by either calling the approve or increase allowance methods on an ERC20 token, with the approved spender's address passed as the first argument. In this attack, the approval was odd because it was not for a smart contract spender, but for an externally owned address, or EOA. While there are some centralized exchanges that use EOAs for transferring tokens into and out of the exchanges, the attacker's EOA had conducted relatively few transactions. When this odd behavior is combined with the over 600 EOAs that provided approvals to the same EOA, the pattern of the attack is visible. To catch these types of anomalies in real time, we could write a Forta agent, which is a script that monitors blockchain activity to detect certain scenarios. Let's see how we could use the JavaScript SDK to build an agent and test it on the exploit transactions. One way we could detect this is to listen for approval events emitted from token contracts, filtering for those whose owner and spender addresses are EOAs and whose transaction count is below a threshold. On every mined transaction, the handle transaction function of the agent is called. In this function, we first check to see if there are any approval events. If so, we filter out EOAs that are likely centralized exchanges, we filter out the black hole EOA, and we check the owner and spender addresses to verify that they are EOAs by calling the ethers.js getCode method with our JSON RPC provider. If both addresses are EOAs, we check the transaction count for the spender EOA to filter out newly seen centralized exchanges, then store information about the approval in an object containing the spender address, owner address, token address, and block number. We could then track the number of approvals that accumulate for each spender EOA over a number of blocks, creating a finding if that number exceeds a threshold. Now let's run this agent over some of the exploit transactions to see the findings they generate. The attack occurred over the course of a month, so for the purpose of displaying results here quickly, the agent has been modified to accelerate the processing over the first 6 hours of the attack. After nearly 1,700 blocks, the agent creates a finding showing that the attacker EOA has successfully received 14 approvals, with the victim EOAs and associated tokens displayed in the finding metadata. Having tested the agent on previous blocks, we can help defend against similar attacks in the future by deploying our agent to the Forta network. We create an agent image with a single command, copy the resulting image reference, then go to Forta Connect to complete the deployment. We provide all of the necessary information in the Forta Connect UI, including pasting the agent image reference, then click Create to deploy our agent on a Forta scan node. For a deployed agent, we can view its information in Forta Connect, such as who developed the agent, the repository where the agent source code can be found, and the agent ID. We can then follow the link to Forta Explorer, where we can see any generated findings and runtime statistics about an agent, and subscribe to alerts from agents by providing either a Slack webhook or an email address. As we demonstrated here using Forta agents, anomalies in any protocol can be detected as soon as they occur and allow for quick response times before users are aware of any issues. To learn more about how you can start building your own agents, check out the Agent SDK documentation at docs.forta.network. Thanks for watching.